right?
Well, yeah, but it'll probably end up being front loaded, and I'll probably do it in such a way where I front load it with some kind of interest bearing token like Aave ETH. And then every time I do a distribution, I'm just swapping from Aave ETH to ETH and sending that out. I would just periodically top up the contract myself. Like, I don't think I'm going to get that sophisticated with like when the user's assets come in, I swap them. I'm just going to make a way for me like on the back end to swap assets or make an easy way for me to like manage the assets that are in there.
Got it. And what kind of exchange rate are you going to use then? You're just going to manage that?
Yeah, I was looking at, so I used to work with Teller oracles a lot, so I was going to use their oracle. I know that they're on Matic, and I know the team. They're based locally near me, so I'm probably going to use that, and I'll probably just update that, just make this thing like an hourly distribution or something.
That's really cool. I think I would probably use that. Like
I know, right? Yeah, great. I'm glad you would. It's good.
Salary streams, right?
Now all I need is my mainnet API key, and I'm good to go.
Don't worry. When your contract's ready, we'll deploy it. Don't worry about that. We'll
yeah, no, I'm not worried. I'm just joking.
We've got an extra person helping us with code reviews as well, so we can we can do that a bit more efficiently now.
Yeah, that's very good.
All right, I got the stream back up. I got it up. I had the wrong key, so we were using a key from the last stream. I didn't know it changed. I thought it was the same key, so I apologize. Welcome everybody to the Scaling Ethereum Superfluid Meetup Hangout session. We're going to be answering questions. Join us in the Discord, discord.superfluid.finance, and then jump into the chat, ask your question, and then we'll bring you up. You got to enable push to talk. So you go into your little audio settings in Discord, find a key, pick a key that you like to press a lot, and then when you press it, then you can talk. So yeah, we've kind of already started a little bit, but I didn't mean to cut you guys off. I just wanted to give the intro one more time. So, well, welcome everybody.
Yeah, welcome everyone. Let's see who could go next. Acid Bird, are you hacking something? I mean, I love the image with the red bird, but I don't know if you're a hacker or just curious. Okay, George, I know you've been looking at our SDK tutorial. Can't hear you. I think you have to push to talk. No, we still can't hear you. But you've got a really nice cat in the background.
Acid Bird, I think, won the auction.
That's what I heard as well, yeah. One of the auctions. Okay, George, I'm sorry, we really can't hear you. Maybe try and change your microphone. In the meantime, maybe Skyhawk, are you also hacking at Scaling Ethereum? Pat, I think the push to talk is really challenging.
Maybe we'll take it off for now and then put it back on for the next. Oh, there's somebody.
Can you hear me?
Yes.
Yeah.
Oh yeah.
Well, I'm just new here, so I'm looking into some stuff, but we've got a lot of plans lined up. And the first thing we're going to be setting up some lists and sending out some tokens, and I've worked for quite a while in things like optimization and artificial intelligence, and I'm interested in looking how I can do some good prediction and find ways to optimize interactions and trades things like that. But we've got a lot of things going on, and we're quite interested in this whole thing. I'm with Prediction Duncan, which you probably have seen around here as well, and basically that's it for now. Just starting to dig in.
Fran, we can't.
Okay, so
Yeah, Acid Bird. Hey.
yeah, hi. Well, actually, I'm very interested in the protocol, and I'm not hacking at the moment, but I'm curious to listen what people are doing, how it can be used. Maybe I will use it somehow. And yeah, I want the third one, the third option. I love it. It's actually the protocol is very nice, and there are a lot of ways how it can be used in the future. So great that I don't know who came up with this idea, but the idea is perfect. Like it's really amazing how it works.
What do you mean? Do you mean the idea for the auction, or in general streaming?
In general, the flow of the of anything. I mean, of the tokens. The auction thing will be huge, I'm sure, because it's you know, you can front run and stuff like that, and you always have to stream for some period of time. And this new thing I heard about the wages, where you can program and pay your salaries to people without thinking that something, you know, you put the amount for a year and then program for your stuff, and it goes. If you know something happens, you just switch off the stream for a person and done. It's really cool.
Yeah, I agree. I think streaming salaries are just going to be the way we get salaries, right? I think there will be a point where it just becomes the norm. Can you not hear me, Didi?
We can hear you now.
Can you hear me? Okay. Oh, Anchor, nice to see you here as well.
Hey, Fran.
So Anchor has started to help us as a code reviewer. So he's the person I was telling you, Mike, that can help out by checking your code before it goes live. So looking forward to see that. Who else is in the chat that's hacking? I see Butler and the third strings and the third stringers. I don't know. Are you a hacker? Is that your real name?
I am not a hacker. I'm just interested in Superfluid. I plan to delve into blockchain development for the first time in the near future, and Superfluid caught my eye, so just trying to stay up to date. That's all.
Nice. So you're a developer?
Yeah.
Nice. Well, I mean, we're super excited to see people who are, starting out in blockchain development and find us first, right? Because I think after you've tried streaming money, everything else feels different. So it'll be interesting to see what you come up with as your first application. There's going to be more hackathons coming up. So even if you didn't sign up to Scaling Ethereum, I think there's another one coming soon called, I think, Hacking Money or something like that. So yeah, there's going to be more opportunities, and if you post in our chat, we can definitely kind of pair you with someone who might be looking for a team.
Oh, that's cool to hear. All right, I'll keep an eye out. Thanks.
Nice. Well, Me9, I think I've seen you around. I don't know if you're. Are you a hacker? Oh, wait. Oh wait, Me9, I know you. You're building Primer, right? Okay, not speaking.
You're very quiet. I think he's trying to talk, but he's very quiet.
Paulo? Yeah. Can't hear you, Paulo. Yeah, can't hear you. George, did you figure out your mic? No. No, I still can't hear you.
So close.
Damn it, these microphones. All right, well, does anybody want to share anything they're hacking on? Otherwise, maybe Pat, you can show off what you were working on and showing earlier. Oh, Me9. You got Me9.
Hey, can you guys hear me?
Just one thing,
Yes.
if I could.
Okay. Oh, so
we had talked briefly about how we wanted to stream rewards, and we're going to be working on a pool which you can lock for different periods of time, and depending on how much time you lock the pool, you get greater rewards. And we wanted to automatically stream these to the user. So one of the things that I would like to learn about is the mechanism for interacting with an existing contract to cash those rewards and take them in and stream them. So we'll be looking at that in the next little while, but probably we'll be looking for a little bit of assistance there, direct us in the right direction.
Sure, sounds good. I think maybe Pat, you could share the soda machine example afterwards and go through how it works.
Yeah,
I think that's a good example because it's basically a contract that opens streams to. It's a soda machine, right? So you kind of pay it and it sends you back soda. So it's got this deposit of soda and it opens streams to the customers. So that could be a potentially good example. Maybe we can look at it in a minute. But Me9, I wanted to hear about you too because I know you're building something pretty cool.
how do you know that?
Because I found you on the list of.
Okay.
Found yours on the showcase page.
Cool. So yeah, we're thinking about using Superfluid for NFTs. I think a few groups might have done that in the NFT hackathon, so that when they use NFTs for payments, they don't have to pay everything up front. They can pay a little bit at a time. I think it was Boundless, maybe was the name of the NFT project that did that.
Oh yeah. The art NFTs, yes.
Yeah, their project is a little different than ours, but we're basically making a marketplace for freelancers, and yeah, the idea is to leverage to gamify it, to leverage the advantages to the freelancer. Yeah, we're looking for divas who wanna become freelancers on an NFT marketplace, basically.
Nice. I think a lot of people want to NFT themselves and become payable by the second. So
exactly,
you won't have a hard time there. Maybe you can get Paris Hilton to issue an NFT of herself.
Everyone is welcome. But we're actually, if anybody wants to help with front end stuff, we are short a front end person.
Oh, nice. Interested. There is actually somebody in our community that was asking for a front end position. Maybe later we can connect you with someone.
Okay. There's one question I kind of wanted to ask about the streaming. So it seems like there's like the streaming is a pretty easy thing to achieve, but then to have transactions also on the back end is a little more difficult to automate. Mm-hmm. So yeah, I'm wondering if there's other like common solutions for doing that, or if it's something that people usually intend to do manually, kind of like what Shepherd Blue, I think, was talking about how he's going to do his.
What do you mean by transactions in the backend?
So if you're streaming cash and you want to DCA that same stream into another coin, then you'll have to make a transaction. So I'm just wondering how people are, or if people are automating that at all, and if they are, how.
Yeah, I mean, ultimately, you can't automate transactions, right? So one
Yeah.
of the reasons we built Superfluid is so that if you do want to automate a recurring payment, a simple recurring payment, then you can do that, right? So you can open streams, which are effectively a way of transferring money over time. But for more bespoke transactions, ultimately somebody has to trigger them. One thing you can do is embed that transaction into other interactions in your platform, which is, for example, what Compound does. So with Compound, you accrue comp tokens when you use the platform, right? And they only distribute them to you when you do an interaction. So, for example, if you open a position or close a position, they will accrue the tokens you've earned thus far. So that could be a model where basically, in the case of, for example, Shepherd Blue, you open streams, and then at some point in time, if another user opens a stream, then they trigger the distribution, right? In that case, you don't have to do it manually. But otherwise, the easiest thing is just to make a Node.js bot that will kind of automate it in the backend.
Yeah. Okay. Shepherd Blue, I wanted to let you know that there's another person who's working on a DCA engine who you might be able to look at his work and see if you could use that for the transactions. If you're interested, you can DM me.
Cool.
Yeah,
Is
great.
that also
Thanks.
for the hackathon?
What's that?
Is that also for this hackathon?
No, it's for a different project, but our hackathon project is sort of affiliated with that project.
Oh, cool. Very cool.
Yeah.
Nice.
Yeah.
So somebody was asking in the Hangout, what's next on the Superfluid roadmap? Mike, would you like to answer that?
Yeah, so one of the things we're trying to do is to make it easy and simple to build with Superfluid. And at the same time, it's working with our dashboard to make users understand what's going on in Superfluid. So we're trying to simplify the access to both a visualization or an understanding of what's going on, and also a toolkit to build with the Superfluid Lego pieces. So that translates into better documentation, better SDK, better code base, better dashboard. Those are all things we're working on the short term. We're also partnering with quite a few Web3 projects to simplify onboarding onto Superfluid, on-ramp, off-ramp, and interaction integration with Superfluid. So one of the things we're working on is related to DAOs. Another thing we're working on is trying to make it easy to connect wallets to Superfluid dashboards. So at the moment, MetaMask is the only one which is really working well. And we are trying to have other wallets, and especially the ones that are used by, say, projects or DAOs to work well with the platform. And going forward, we'll try to basically listen to everything that is coming to us from you guys that are, every engineer, every developer in Web3, to understand what we actually need to build for you to build with Superfluid in an easy way. So, you are the only people we need to serve in a way at the moment. So come to us with all your questions, requests, and feature requests, because we'll probably have time and firepower to build those for you. So if there is anything that seems a bit clunky or not working properly, let us know. For the longer term, we'll probably want to decentralize a little bit, but it's still early days. Like before we do that, we need the protocol to be very robust. We want it to be secure. We want it to be stress tested. So we are still in beta at the moment, meaning we want to still get out of the testing phase. And then we'll probably try to service as many projects in Web3 as we can. I don't know if that answered your question, but I hope it does.
We've got a question now. How can you discuss a little how Portis wallet integrates with Superfluid? I just saw a previous project, used it with you guys, figured it'd be good info for the stream. Yeah, which project was it that used Portis wallet? I think that was probably during the NFT hack.
No, it was, I think the project he's referring to is Deflix, which was from the Etherpunk hackathon. So they actually built a really, really cool integration with Portis. So Portis is just another wallet, right? But they have this pretty interesting feature where you can trust an application. So if you trust the application, you then don't have to confirm interactions anymore, which means every time the user clicks a button in your application, which does some kind of Web3 interaction, it doesn't trigger MetaMask and then you have to press confirm again. It just confirms it. So as a result, they were able to create this really neat interface where you basically, you paid for every second of a video you were watching. So you clicked, it would start a stream, confirm it automatically, then you would pause the stream and it would close the stream automatically. And this was all happening through the kind of Portis integration. So yeah, definitely if you need this kind of very kind of automated integration, I think Portis is a good choice.
Yeah, it's quick. It's like, yeah, there's no MetaMask getting in your way, right? It's like, hey, I want to watch this video. Okay, done. We're streaming money. Here's your video.
Exactly. Here's your video. Stop the video. Stop the stream, and you get to pay for only what you watch.
Yeah. Let me pull that up right now, actually, because I think that it's pretty cool. Let me share. Yeah. All right. So I'm dual streaming now. I'm streaming on Discord and on YouTube. All right. Deflix. Cool. So we got a video here, play and pause, and this is, I'm pretty sure, triggers the Portis wallet. There was the full submission has like more information. I think they kind of simplified it since then, and that's good that they're, making improvements.
Still working on it a bit.
Yeah. So, but in the Devfolio, I'll throw this in the chat so you guys can poke around. It's got the GitHub repo, and I think this is sort of the view that I was thinking of, where it's got all the movies, and then you just click on it, and then it just starts playing. That's pretty cool.
Yeah, I think it was a pretty cool application. It won our prize, and since then they've kept working on it. They're coming up with some pretty cool ideas to turn it into a real product. And yeah, I think there's something there. There's something there. Especially the coolest thing here is that every video is an NFT. So whoever owns the NFT is actually receiving the income, which means that it's effectively like licensing the videos, right? So you can sell the NFT, and that would sell the future views of the video itself. And I think that's just kind of brilliant, honestly. So yeah, looking forward to see what they do next. But yeah, here's the license dashboard, right? So you could create your video NFTs and then transfer them to others.
Yeah, that's kind of cool.
But yeah, Pat, why don't you show them the soda machine? I think Me9 was asking how to open streams in a contract. So I think the soda machine is a good example.
Yeah. Okay. Well, so the soda machine example is down at docs.superfluid.finance. On the left-hand side, if you scroll down past the tutorial and the docs, you'll see the examples, and then you hit the arrow to open up the examples. And I should have it like linked in this document, but yeah, I'll clean that up. I'll make it more clear. But so there's two main tutorial super apps that you can go through. You can go through the tutorial, which is like the official tutorial. And this is going to take about an hour if you're coding along and about 15 minutes if you're just reading. And that's going to cover everything from start to finish for Superfluid, including super apps. And in that one, it's the Holy Grail example, which is an NFT. And the one that we made for the Scaling Ethereum hackathon is a super app that deals with incoming and outgoing streams. And it's not an NFT. It's similar to the Holy Grail example, but this one, you put in dollars, you put in DAI in a stream to the app, and in return, you receive a token back. So it's $1 or 1 DAI is 1 soda, and it's based on the rate. So however fast you pay the soda machine is how fast the soda shoots out back at you. So let's see. So I guess the question is, how do you do that in a super app? So I'll click on the Remix link here and we'll open up the Remix tutorial. Alrighty, so the magic is happening in the soda machine contract. And if you click the link in there, you'll get all these contracts automatically. And really, it's this one function, update outflow. And here we have 3 different cases. So we have, let me make this a little bigger and make this a little smaller. We have if the flow rate is not 0, if the flow rate is 0, and if other else, right? So basically we're just checking to see if the incoming flow, we're checking the flow rate, and then we're checking the existing outflow rate to say, do I already have soda flowing to this person, right? Because they could pay $1 a minute and then start paying $2 a minute, and then we need to know what's happening. Do we need to update our existing flow? Do we need to create a new one, or do we need to delete it? And so all the logic is right here. Is there a specific part of this that was confusing when you were thinking about returning a stream of tokens?
Yeah, I think the boilerplate is a bit confusing, right? So when you open a stream, this is the whole call you have to do. So there's a lot of boilerplate. So maybe it's worth unpacking that a tiny bit, Pat.
Yeah. Okay. So sure. So the host. Let's start with that because that's kind of the beginning. You can ignore this context stuff for now. That's more advanced stuff. What we're really doing here is we're calling the host contract, and that's like the engine of Superfluid. So that's where everything flows through the host, right? The host is the orchestrator, the conductor of everything. And we are calling the function call agreement with context. For now, let's not worry about with context or anything CTX context. Let's just look at this call agreement. Okay, so we're telling the host, hey, host, I want you to call this agreement. And the first argument we pass is the address for the constant flow agreement. So we're just saying, host, I want to do something with a constant flow. And the host is like, okay, sure. What do you want to do? And the next argument that we're passing is an encoded arguments for what we would call on the constant flow agreement. So this is essentially, we're taking what we want to do and we're packing it up using this ABI.encode with selector. And all this is basically translating what we want to do, what we would call if we were just clicking a button on the, on an Etherscan or one-click dApp or whatever, but it's packaging it in a way so that we can hand it to the host and the host actually knows what to do with it. And I could go like pretty deep into that, but we're just encoding it and we're giving it to the host as an argument to what we want to do with our CFA. And so for now, you can just copy and paste this. And I understand it's a lot of boilerplate, but once you use it a couple times, it'll make sense. Okay, so now that we know that we're packaging something up, we're giving it to the host and we're saying, do this with the CFA. But what is the thing that we're packaging up? Well, let's look at that. So the first argument here to encode with selector is the selector for the update flow function. So we have our CFA contract that deals with constant flows. There's a function in that contract called update flow, and we're getting the selector for that function. And what that does is that allows us it allows this to know which function we're talking about, right? So a function selector is specific based on the name of the function and the arguments and types of arguments that you should provide. So you can just think of this as like an ID. So we're saying the ID for the update flow function, that's what we're targeting. And then everything after that is our arguments for that function. So let me take a step back one more time. So on the CFA, there's a function called update flow, and update flow takes some arguments, right? And so we're saying we want to pick the selector, the ID for update flow. That's the thing that we're trying to call on the CFA. And here's the arguments that we're passing. And then we're wrapping all of that up in encode with selector, and we're passing it to the host. And we're saying, hey host, call the CFA, and here's what I want you to call on the CFA. And that basically, that all this is doing is allowing us to have everything flow through the host contract. And when it flows through the host contract, then it becomes part of the protocol. We can't just call the CFA directly. We have to go through the host because the host, again, is the orchestrator here. And so if you want to think about this and you want to make it easier for yourself, just go to the CFA contract, look at the update flow function, and actually we can do that right now. And you'll see what sort of arguments you need to put in here. Basically, it's the token that you want, the recipient, and the flow rate that you're looking for. Let's see. Oh, it's not showing me. Oh, I need to compile. That's right. Let me compile. Does that make sense? Is there any part of that that doesn't make sense?
Makes sense to me. What are you guys using for development? Is everybody here using Remix, or you guys work locally with Truffle?
I tend to use Hard Hat.
Hard Hat.
I use Hard Hat.
Nice. Didi, what do you use? Can't hear you now. Some microphone problem. Sorry. Tell us in the chat. So Brian is asking, I assume there's just one host per network controlled by Superfluid, and any super app or agreement you make needs to be approved and registered with the host. Can you elaborate where the parts played by Superfluid and external devs? So yes, you're correct. There is, I mean, there can be more than one host, obviously, but we are working through one host, which is controlled and upgraded by Superfluid. So the reason we upgraded is, like Mike said, we're still in beta. There's still a lot that's changing. We've done quite a few upgrades since we launched, and we're adding new functionalities. We're fixing bugs. There's there's stuff that we're adding. For example, we recently added meta transactions. So there's still a lot of ongoing work on the host itself. And yes, you're correct. So basically, any super app or agreement needs to be registered with the host. So the way this works is you register it with the host, and then the host knows that when you, for example, you send a stream to the soda machine contract, right? So the moment you open a stream encoding the address of the soda machine contract, the host will check if that address is a registered app, right? So if the address is a registered app, then it will go and check, is there any code I need to execute, right? So if you don't register your app with the host contract, it won't be able to know it has to execute code. So that's why you need a central host contract, right? And it's one of the reasons why we are able to offer these callback functionalities that make Superfluid so powerful.
Yeah.
Does that answer the question, Brian?
One thing as well is during the registration. Oh, sorry. Go ahead, Brian.
Yeah, that makes sense. I appreciate that. With the registration process, is that something that is independent on the developer side, or is it something where we like register and then you guys have to give us a access or a key or something like that?
No,
So,
it's on the smart contract side.
So do you mean to register apps? Or what do you mean? Like, are you talking about apps or for agreement?
I would say for either, because it sounds like you guys are alluding to like people writing agreements, but I wasn't sure. I'm just trying to figure out the line between like what stuff can devs do without having to ask you guys for anything, and then what things do we have to ask you guys for? And it sounds like when you register a super app, that I guess intuitively I could see how the host would just like see it and it's registered and that's great.
Yeah.
But I didn't know if there's any like gatekeeping or steps we need to take to check with you guys before, or can we just run with it and go nuts?
So that's a good question. And the short answer is we want it to be completely free and open, and it is on testnet. Currently on our mainnet deployments, we are gatekeeping just so that we basically can check your code and do some basic code review, because it's cutting edge stuff. It's very easy to make contracts that will break. And, I've made my fair share on testnet of contracts that broke the first time they were used. So we're starting to learn a few tricks and stuff. And I hope we'll be able to, I hope we'll feel confident enough to completely remove the gatekeeping very soon. But for now, it's still there on mainnets. But we haven't, we let anyone who wants to deploy. It's not something we want to block. We just want to check your code to make sure it's not going to break. Like, we're hoping I think the worst user experience is when you think everything's going to work and then it doesn't, right? So if we can offer that extra help and just kind of, double check. Sorry, and on the agreement side, it's definitely something that needs to be gatekept. So agreements are immediately available to everyone with super tokens, right? So they're immediately available to all super tokens and to every user. And as such, they really need to be carefully chosen and vetted and tested very thoroughly. Like they're a vital part of the protocol, right? While apps are kind of sitting on top, agreements are definitely a part of the core. So the process there is definitely slower, more careful, and more, let's say, committee driven. Like, it's not like one person wants to build an agreement and we publish it. It's more like we have an idea for agreement, we get together, we design it, somebody implements it, then a lot of people review it, and then finally we go live after after we're confident it's not going to break, because effectively an agreement could break everything for everyone, while an app can only damage itself.
Yeah, that makes 100% sense. Totally get it. On mainnet, what form does the gatekeeping take? Like, how does that manifest? What do we have to do to work on mainnet?
So at the moment, it's an API key. Basically, you need to put it in when you register your app. So in the constructor, Pat, can you show the constructor?
I think I am, right?
The screen's not moving for me. Oh yeah, sorry, you're showing the constructor, of course. So here it's a host register, right? So this one works in testnet, while in mainnet there's a different one, which is host register app with key, and you need to put in an API key, and that will register your app. But we're moving towards a slightly more efficient model with not reusable keys, but kind of where you can register a factory. So if you have because a lot of applications we've seen, for example, tradable cash flows, effectively you're going to create a lot of them, right? So you need to be able to register a factory. So that's the next thing we're going to kind of deploy very soon. But for now, you basically just need to put this key in when you register the application on mainnet. But again, we're not keen to gatekeep. So if you are ready to deploy the key, no problem.
Let's see, what else? What else is confusing about the callbacks? Are callbacks confusing, or are those pretty straightforward?
I don't know. Anchor, what do you think? Are callbacks confusing?
I mean, to me, they're pretty straightforward, I guess. Only the only thing that I was slightly confused about, like, why shouldn't you be able to terminate in after agreement, after agreement termination? But yeah, after thinking about it more, it kind of makes sense.
Right. So yeah, that makes sense actually. Let's go over that quickly, Pat. So I'd say the callbacks are basically a way to their logic, right? So when you open a stream towards a contract that's registered as an app, it will trigger callbacks. So there's there's 6 callbacks. There's before and after callbacks. So before callbacks are triggered before the stream is started, and after callbacks are triggered after the stream has started or has been changed. So the created one is triggered when you open the stream. So it will execute the logic here. Then, Pat, if you can scroll down, there's the updated callback, which is triggered when the stream is updated. And then there is the terminated callback, which triggers when the stream is closed, right? Now, the problem with the termination callback is that while obviously, as an app, maybe you don't want somebody to send you money, right? So what you can do is in the after agreement created callback, you could potentially revert, right? So for example, they send you too little money and you're like, no, revert, I want more money. But in the after agreement terminated callback, if you revert, then basically you're not allowing them to stop paying you, right? So because we can't allow an application to hold its users hostage, we had to basically make a protocol level decision to basically say you can't ever revert a call in the termination callback, because if you revert, you're basically holding users hostage. So if you do that, your app will be jailed. So the jail is basically this mechanism which strips out the callbacks and it basically unregisters your app. So you have to be very careful when you're developing with Superfluid that you never revert or require anything in the termination callback. So that's why, for example, you see here that it doesn't use the same modifiers as the other ones, and instead it uses these if clauses. So on line 152, it's basically instead of reverting, it's simply returning without doing anything, right? And the reason for that is if it reverts, then the app would get jailed. So yeah, I guess that's the quirkiest thing in the callbacks that you have to always remember. And it's actually the main reason we're gatekeeping, because it's very easy to get this wrong. So it's one of the things we would immediately check if you submitted an app for mainnet.
And what happens if your app is jailed?
So if your app is jailed, basically, if the next user to open a stream towards your app won't trigger the callbacks. So the money simply goes into the contract as if it were a contract with, but not a super app anymore. So you really want to avoid this because basically you can't register again. So if your app is jailed, your contract's bricked. So you got to be really careful. Obviously, it's not impossible to avoid it, right? Because you're writing the code, so you just have to avoid requires and reverts. But you have to make sure that there's no code path that would allow for a revert or a require in the termination callback. So you have to be very careful with data and providing all the right data and never providing the wrong one. So personally, every single contract I've written, I've made that mistake at least once. And then in my tests, I would check, there's a call that's host is app jailed, right? So check, and my app was jailed. So I always put that in my tests to make sure that, I'm not jailing my own app in my test cases. So generally, if in your test, if you have a comprehensive test suite and you never get jailed, then you're probably fine.
And what happens if it's jailed and then other users try to terminate? Does the callback still not get called then? Like none of the callbacks, not even the new agreement or after agreement created, even the terminated agreement callbacks.
Your contract is not a super app, basically.
Ooh, that's scary.
Yeah, so you gotta be careful there. Again, that's Brian, if that answers your question, that's the main reason we're gatekeeping, because it's very easy to forget this detail and get your app basically not working. So we've seen this happen with our. So it's definitely something that if it's the first time you build something on Superfluid, you wouldn't probably be careful with.
And what happens if you're using? Oh, sorry. Go ahead.
Yeah. So I mean, if you could go over how to deal with the context and when to return it, that I guess that might be also helpful, because that was where I was stuck for maybe a couple of hours. I was creating a loopback stream in response to a stream, but I was not returning the context, so my app was also getting jailed for that reason. Maybe you might want to go over that also.
Yeah, sure. So the simplest example is getting the message.sender, which is important for the terminated agreement terminated, and not so much important for the other ones, but we just use it so that we can be consistent. But what we're talking about here is this context, which is data that gets passed around between the callbacks and the host and the CFA, and basically this is, I don't know, what's a good analogy for context in a real world. This is
Meow says it's the envelope.
Yeah, it's an envelope, and people can put stuff in the envelope and hand it off to the next process. And so the reason this is useful is let's say we're in the after agreement terminated, and we need to know the address of the customer. It's not always message.sender, right? Because message.sender could be the agent who's closing a stream because they didn't have enough balance or something.
It could be the receiver as well, right?
Or the receiver.
A stream could be terminated by the receiver as well.
Yeah, which is interesting, right? So the app could close the flow to itself, or the user, the customer, could close the flow. And in both cases, we still need to know who is sending the flow. And so we can't just use message.sender. We have to actually decode agreement data. Actually, this is for agreement data, but we could use context for other data as well. Yeah, I guess that's a good question then, Fran. So what's the difference here between context and agreement data? Are they both envelopes that we're passing around?
No, so agreement data is very specific to the callbacks. Context is basically the way we ensure that there's no, one of the reasons is reentrancy, basically. So the way we ensure there's no reentrancy is by having the context. So the context is basically, you can imagine it like an envelope, which gets stamped by the host, right? And the host needs to know every time the envelope is changed, right? So they stamp it again. So if you try and change the content of that envelope without going through the host, right? So you try to modify some data, or maybe you try to open a new stream without letting the host know that you're part of this application, then basically the stamp will be broken, right? So the host will immediately notice this and will revert the call. So the context is a way to allow all this kind of complicated stuff to happen, all this message sending across 3 different contracts, while maintaining integrity and avoiding reentrancy. And the thing Anchor was mentioning is that basically you have to always pass the context, right? So every time you're in your super app and you're interacting with the host contract, you have to make sure you're always passing the context, and the host will pass you the context back. And at the end of the callback, you have to return the context. So if you look at all the calls that happen here, there's always this context getting passed around and returned. And that's something that will get, basically when you start developing, you'll forget about it, and your app might revert in your tests, because basically maybe you forgot to return it once, or maybe you modified it twice, and then you'll get this error, which is like basically tried to modify context without telling me, or something like that from the host. So the host is very precious about this, and you have to be very careful that you always pass it. So Pat, if you go to the update outflow call, here you'll basically see that when you open a stream, right, you basically pass the context into there, and then you return the context as well, right? So you always have to pass it and get the result. And if you're opening 2 streams, you have to pass it, get it back, then pass the new one, and then get back the new one, and then ultimately return the last context you got. So yeah, like Anchor said, this is something at the beginning you're going to bash your head against the wall a few times with, but then it just becomes a habit, and you just remember to always pass it around. And like Patrick was saying, the context carries some useful information. So it carries the information regarding the message sender. So the reason we use context to pass message sender is because you are not calling the token, right? When you open a stream, you're calling the host, and the host is calling the CFA, which is operating on the token, right? So there's 3 contracts involved, and they have to know who the message sender was. So the message sender gets encoded in the context, which is then passed around through these contracts, right? So that's another reason why we have this variable. Again, it becomes second nature, but at the beginning, it might be a bit confusing.
Any other questions? We're getting to the top of the hour here, 5 minutes over actually.
So Brian is asking, could you talk about the current config word options? Sure. Yeah. Could you go to the top here, and we can look at what's in there? Right. So the config words, at the moment, you basically use it for one thing, which is just saying which callbacks you're not using. So obviously you could include the callbacks and then just leave them empty, right? That would work. but sometimes you want to save gas, right? So you can put here in the config word that you're not using some of the callbacks, and it will skip them in the when you open a stream, it will skip the before callback, right? For example, in this case. The other thing you see here is app level final. So this is something we still haven't finished building, but ultimately we would want you to be able to have multiple levels of super apps. So you can create a super app which triggers some callbacks and calls another super app which triggers callbacks again. So in that case, you would have a first level and a second level, right? We have some working things on testnet, but there's nothing that we've published yet because it's very unfinished. But there will be potentially, if we manage, there's still kind of really hard problems here to solve, but ultimately you could be able to create apps that are not final. So final means that any call from this contract to another contract will not trigger callbacks, even if the receiving contract is a super app. But if it weren't final, if it were something else, then when this super app opens a stream, if the receiver is a super app, it will trigger the callbacks again, if that makes sense. Yes, exactly. At the moment, they're all final, so you can't chain them. Unfortunately, it's a very, very complicated engineering. So at the moment, that's the situation. I think we'll be able to do that in the future where you can chain them. But keep in mind that these calls get fairly expensive. So at some point, that would also be a problem. I think on some scaling solutions, like for example, rollups, where the gas limit is very high, we might be able to do this in a better way. But basically, we have to be careful with, right? So what we were saying before, we must ensure that the user is always able to terminate their streams, right? And if any of so think of it like this: I open a stream to your app, right? And now your app is not letting me close the stream. That's obviously bad, right? So we need the app to always allow me to close the stream. However, imagine that I'm chaining super apps, right? So now I've got 3 super apps involved, and one of them is misbehaving. So in this case, it becomes extremely difficult to know who to punish, which is the reason why it's very hard to fix this problem.
And right now, if my super app is opening a stream and it opens it to another super app, it's not actually calling any functions on the super app. Does that count as chaining, or is that considered something else?
It's not going to call the functions. You can still do it, but it won't trigger the callbacks.
Okay, and that's because right now we have to use app level final, and eventually we'll get to do chaining, but for now it's not going to trigger anything. Okay.
Yes, exactly. But yeah, I'm curious, Brian, what would you do with chained super apps?
Feel free to unmute yourself as well.
Yeah, I think I keep muting myself. Yeah, I think I was throwing out some ideas with a friend yesterday, and something that occurred to me was I know there's been a lot of value streaming with NFTs, but I think there's at least a couple simple cases where you could have one object or entity represented by an NFT that has value being streamed into it. And then maybe once it hits a certain threshold, then it starts streaming to another. I mean, obviously you could have cyclical issues, which I was curious how you guys would solve that. But yeah, I mean, that's where my head went to first when looking at your documentation, just, trying to invent something different and new, is kind of chaining these streams, which if you think about, I've worked in video streaming in the past, and I think it's very analogous to what you guys are doing here with streaming stuff with Superfluid, where you don't have to cache things at every single box in your distributed system. You could technically have several microservices streaming to the next, and you get efficiencies there. Yeah, I think you do the same thing with dollars, where you know, maybe the first part of the stream is someone getting paid. It goes into like a Yearn vault, and then if Yearn ever supports Superfluid, then Yearn is redirecting to another one. And obviously, you can get into big trouble there if you know, like Fran was saying. But I think it's some really cool. You can almost have this graph of all these streams going into each other, and it's just money flow versus discrete spiky payments.
So keep in mind, you can do graphs. You can chain streams. You can do that now. We did the first thing we did when the contract was deployed. So it was deployed by a community member, but as soon as we knew it was online, it was working for our dashboard. We actually created a ring of streams. So everyone in the company was streaming to someone else, and we were connecting all of those, right? So you can definitely chain streams. What you can't chain is super apps. But yeah, I see where you're going with these. It's definitely something to figure out.
Yeah, when he said microtransactions, my brain just kind of exploded. Or micro, what's the like serverless functions, but it's money instead of serverless functions.
So it's like when you pipe stuff between things in a system, you know, normally like a naively you would download the entire movie, and then you wait till the movie's being downloaded, then you can start watching it, right? Or if you're doing, let's say you're processing a movie, right? And I used to work in this area where you don't download the whole video and then do facial recognition and then do OCR and then you kind of do it in a streaming fashion so that you don't have to download the entire video. You don't have to, so you're operating on chunks. And so you don't have to have a huge box with gigabytes of memory the same way you don't have to store millions of dollars, you know, in an account before you actually start to move it, or even $10. It could be fractions of a penny. And you could be streaming that in real time as opposed to having to wait for the value to build up and then spike and flow to another system, you know?
Yeah. That's really awesome concept. That's going to get me, I'm going to be coming up with some tutorials next on micro transaction spikes and fluid flows and
yeah, it's I think Brian, you should really look.
Go ahead.
You'll find some interesting solutions that we found to make this even possible. And they're really hard problems. It took us a while to figure them out, but I think you're thinking in the right way about how this enables a lot of new stuff and new ideas. Wait, somebody else has joined. Someone new. All right. Well, does anybody else have any other?
Can you guys hear me?
Yes. Yes.
Oh my God, it worked. I can't believe it. An hour later. All right. I have a couple of questions. So, I in the Discord the other day, I told you that we wanted to manage digital asset trusts, and we're trying to figure out the best structure. So, you know, I read in your documentation that the part about agreements, and was wondering, should these be the rules for, say, each trust DAO account, saying that each account is kind of its own address, and that the streaming of dividends or returns on investment, when it's streamed out to the customers, to the individual trusts, would it make sense that maybe we have all of the investments in, let's say, our trust DAO account, and then we stream them to the trust, say, once a month using an IDA rather than a CFA? Would that make best sense? That was probably really confusing.
So I think if you know how much you're going to, then a CFA makes a lot of sense, right? Like if you have a clear idea of how much money you're going to distribute to each individual, then a CFA is perfect, because that's exactly what it will do, right? It will stream exactly the amount you specify to whoever you specify, right? If you don't know how much you're going to send them, but you know proportionally how much you should send each of them, right? So if you have 100 users which have different stakes in your trust, then I would probably suggest using the IDA, right? Because the IDA gives you this flexibility of distributing different amounts, but maintains the proportions, right? And it's very scalable. You can have hundreds of users, doesn't matter, and you can change the quantity every time, right? What stays the same are the proportions. In the case of the stream, what stays the same is the quantity that you send, right? So I think that's the best way to kind of think which to use. And then if nothing stays the same, right? If both the quantity and the proportions change all the time, then you should just use transfers, like regular, token transfers.
Okay, awesome. Also, too, is Polygon, will that enter the mix here soon? And if so, how would it?
So yeah, Superfluid is deployed on Polygon, so you can use it on Polygon already. Transactions are super cheap. They're great. It's a great way to basically save money when you do things, and it works very well. It's just a click away adding it to your MetaMask. You can go to superfluid.finance/RPC, and you can just click one button and it adds Polygon to MetaMask. So it's very easy to use, and yeah, it's available already.
Beautiful. I just have two more for you. Okay, so now if we were going to set this up and structure this, I looked at your NFT example earlier, and would you use? Is it a matter of just using those two contracts and changing them around for our specifics? Like, could we make each individual contract? Let's say we have a certain trust that, say, 25% USDC, 25% DAI, 25% Ether, and 25% I don't know, Aave.
Mm-hmm.
Could you code these contracts that it would distribute that amount to these accounts? Is that how it would work?
So the trust is holding Aave. Sorry, what else did you say?
Four different assets: USDC, DAI, Aave, and Ether. Say.
Okay, and the users are users contributing to the trust in an ongoing fashion, or
yes, they are.
Okay, so the users are streaming in, for example, into the trust, right? They want to invest in the trust.
Yes.
Right. And then you would need some logic to the funds, I guess. Like if you want to rebalance, maybe buy more Aave or buy more of the other assets, right? That's one function you would need to have. And that's something that you would probably need to trigger manually, I guess. And then the other thing you mentioned, I think, is dividends, right? You would also want to distribute dividends.
Yes.
Right. So to distribute dividends, you would probably want to use an IDA. Like, I think it's a really good way to distribute dividends. What you could do is that based on the size of the stream that people are sending to the trust, you give them a proportion of an IDA. So by doing this, basically, you already have all the information, right? User opens a stream of, say, $100 a month. Then you give them 100 shares in the dividends, right? And then when you distribute the dividends, they will get their proportional share of those dividends. So basically, you can tie the stream as a contribution to their stake in the dividend distribution simply by programming this in the contracts. We haven't done anything of this sort. It's very similar to what Shepherd Blue, who was in the call before, was talking about. So maybe you could check out how he's planning to implement it and work on that. I don't think there's anything in our example repo that does this.
Okay. Awesome. My two teammates are from Australia, so there's a tremendous time difference, and they're thrilled with your project, as am I, of course. We would love to be able to have a hangout with you guys. Is it possible that we could schedule one at 5 p.m. Eastern time, anytime over the next week, that we could chat with you guys and just ask questions, because they have other specific questions and they're changing every day.
Right. I'm not sure what 5 p.m. Eastern time means for me, but probably. Otherwise, Pat is in Eastern time, so he can definitely be there.
Yeah, Pat, would that be okay?
Yeah.
Okay. Awesome. So, all righty. I'll chat with them today, and then I'll try and hit you up in the Discord. Thank you guys very, very much. Great question. Is well worth the wait.
Thanks for coming on.
Really looking forward to see what you're in scaling Ethereum, right? So you're gonna hack this month.
Yeah. Yes, we are.
Right on. Do we have any other questions? Fran, did we lose you? Did it freeze?
I'm still here.
Oh, okay.
Yeah, I saw Meow joined. Wow, we have our CTO Meow here. If anybody has any questions that probably didn't answer properly, Meow, we have Brian here in the Hangout asking some really difficult questions that I've tried to answer. I've tried to relay what I heard from you about final apps, but
I'm sorry.
No, that's fine. That's fine. I like being put on the spot. But yeah, Meow is our CTO. He's the one that built most of the contracts that you've seen, and that basically designed the system. So if you have any questions about what I was trying to explain, he's probably got the right answers.
Okay, we don't have to do it during this hangout, but I did want to just understand better what you mentioned before with you can't chain super apps, but you can chain the super tokens. I just want to delve into that a little bit whenever you guys have time.
Sounds good. Yeah, we could. I mean, to chain streams, it's very easy. Just open a stream. You have two accounts. You use one account, open a stream to the other account, and then from the other account, send the stream back. That's streams are chained, right?
Infinite money.
It's basically like connecting a power cord to itself, but it actually works.
Well, maybe if I can put this a different way to see if I understand it correctly. The super tokens are just a flow, right? Just, in, out, or whatever. Whereas the super apps, there's potentially conditional logic. And what you're saying is you can't have two contracts in concert, with their own conditional logic hooked together at this point.
Exactly. So I think you summarized it. Yeah. You can only build one conditional logic app into one transaction, right?
Yeah. Yeah, you could certainly have it change, but it's not going to execute the logic for the second app. You would have to manually trigger that in another transaction.
Yeah.
So.
Okay. Yeah, because you don't want runaway transactions, right? Where you just have a big cycle of if then else with
Exactly. Basically, the more custom logic there is, right, the more fail. And if something fails, it's a problem because we would then have to determine if it's what kind of failure it is, right? So it makes it simpler if there's only one center of logic for each transaction.
Yeah. Do you guys have any idea when you might? I mean, there's lots you can build without it, so I don't want to put pressure on you. But do you know, is there a time you're targeting where you think you might be ready to start doing something like that, where you can chain super apps?
Yeah. So can I just be quick? I'm just coming here quickly, so I just caught a question. So is that about the final like chain of super apps? And, why the reason that we don't allow one level at this? Is that around that direction?
Yeah, exactly.
All right. So in general, the super app is about management of the life cycle of the agreement. The agreement being constant flow agreement. The agreement could be also in agreement. They have a life cycle because the agreement exists not just one block, but many blocks, right, until the terminate flow or unsubscribe. So that's the general idea of the super app. However, if allowing like chain of super apps, there is a issue regarding how many level we would allow it to go, because the block has a gas limit. If we allow an unlimited number of chaining, and you potentially reach a problem that you cannot unwind an agreement because of chain of super apps. And one of the design principles is that we should allow users to exit the agreement no matter what. That's why we have. That's why the app has some concerns regarding what they can do in the termination callback. Right. So, say if you are sending a stream to an app, and if the app has a bug, does that mean the flow can never be closed? No. So the design principle is that we don't want that to be happening, and that's why we have evidence some errors callback with your app in space. Along that line, the more complicated problem with apps, the gas cost adds up, and you could end up situation that a chain of apps can cost a lot of gas, and that will be unmanageable. There's a limit of how many levels, and adding to that, we haven't found a clear use case to have two levels of app yet. That's why we kind of say that. But having two levels makes it even harder to about the reentrance issue. Currently, one level app makes it easy to think about reentrance because effectively one level, meaning only one level of callback. Once you enter that one level, there's no more callback coming back. So that's eliminate all the having two levels. Then we have to kind of be careful about it. Careful until we are sure that we need to, then we allow that. While also understand what are the use cases, right? So the use case we thought about design the level block type of apps, so that the apps are serving some sort of generic purpose, and the other apps could use those building blocks for their purpose. That's what we thought about, but we haven't found a strong case yet. But folks find one go that direction. But until then, we're kind of being cautious side of allow one level. I hope that.
Yeah, I hope that was helpful, Brian.
I made everyone confused.
Yeah, I totally get. There's a lot of it's a Pandora's box potentially, so it totally makes sense. I mean, I could imagine a couple of use cases, but that doesn't mean that it's like, something that realistically would be like really needed right now. So, it'd be fun, but I get that there's some sharp edges to deal with. So.
Yeah. I think Meow said something very interesting about general purpose super apps. So like if we start seeing super apps that don't necessarily serve like are not final, like in the logic sense, like this is not a final super app, like there's necessarily has to be something afterwards, then it starts to make sense that you would need to chain them, right? But at the moment, everything we see contained, right? People build an app and it does everything it needs to, and that's it. So I guess it's also down to see how people build stuff so that we can figure out how necessary it is to build something that would enable that.
Yeah, I think if I'm projecting like what I could imagine that looking like, it's, you know, a super app, you know, for some use case or for some organization is, I imagine, would be, you know, deployed by that organization, right? So you sort of have these silos of these use cases. You know, and if you're talking about companies or just orgs, very easily I could see value flowing between them. Maybe you chain them through, you know, you connect the super apps via the token flows instead. I don't know if that would be appropriate, but, you know, almost like the whole money Legos argument, right? Like to me, allowing the super apps to chain allows you to compose multiple systems that are independently controlled.
Yeah, yeah, that makes a lot of sense. The main problem is unwinding. The more logic there is down the food chain, basically, the more complex unwinding becomes, and also the more dangerous unwinding becomes. You can think of streams like, in a sense, it's almost leverage, because you're kind of spending more money than you have, right? Although you're not spending it immediately, you're spending it over time, right? But because of that, basically, the longer these stream chains become, the more leveraged the system is. So unwinding them is the main problem. But yeah, I get if we can turn the kind of money Legos into money pipes, or I don't know, money flow generators or something like that, then that could be an interesting to work with cash flows.
Yeah, I just want to mention one point. There still can be chaining of logic without involving super apps. So at the moment you can still have a regular that interacts with another super app. To register that super app, all you want, the reason you would register as a super app, you want to handle life cycle of the stream that goes to your account. So you don't need to handle that with the super app. Still chaining of logic. So far, example that the app part of without so that everything first before really need the
Sorry, I'm missing most of what you're saying. I think it might be your mic or
Yeah,
something.
can't hear you very well, Meow. But I think Meow was saying that you can chain without. I mean, you can chain contracts and logic without necessarily needing the super app framework. So there might be ways to achieve what we were discussing without needing to overextend the protocol, basically.
Yeah, I don't want to make work for you guys. I'm just playing with ideas.
Yeah, no, I get it. Look, I'm very looking forward to for this hackathon. I think we were discussing a few ideas yesterday. You were telling us about the rental platform. But yeah, I mean, ultimately, you'll see that building with super apps is actually quite simple until you start going into more complicated ideas, I guess. Yeah, let's see what you build.
Yeah, I think what drew me to Superfluid among, you know, other projects was I think how, I guess, novel or like interesting and new the concept is, and you guys have pretty good documentation, and the things you need to do to make it work, I would say, is probably pretty minimal compared to some other projects, considering what you're accomplishing, right?
Yes.
So that was, yeah, I watched your video like maybe 3 times through, you know, just trying to kind of catch all the points, but, and again, the documentation was very helpful. So yeah, I mean, that's what drew me to what you guys are doing. And I think it'd be easier to build something pretty cutting edge than maybe some other things I found out there.
Nice, nice. Well,
That's what we like to hear.
We love to hear that. Which video was that you watched free time?
Honestly, everyone I could find, but I watched the I keep forgetting the name. The
Holy Grail.
Yeah, the Holy Grail one. I watched that a couple of times through. Then I found some of the other videos. Yeah, I mean, I feel like they're all, you know, there's a couple times like, you know, you guys would say like, come back and look at this if you need more detail. And that's the great thing about a video is you can go and pause it, reference the documentation, look at contracts, try to understand what's going on. And I'm not sure if I want to use Remix or like Hard Hat. I think there's benefits both ways, but I'll find out as I dig in there. But it's nice that you guys have the Remix stuff where you can literally just kind of click a button and now you're ready to go.
Yeah.
Yeah.
Awesome. Well, I think we're a bit over time. We're gonna be, you know, we're still in the chat, so even if the Hangouts wrapping up, you know, we'll still be in the chats and in the hacking channels. So if you can continue to ask questions there. Fran, did you have anything else? Should we talk about our bounties?
Yeah, bounties. Go for it.
All right, let's see. Hack.superfluid.finance is where good place to start.
Okay, so I remember one of them. So our top bounty for $2,000 is for anyone who can build a cross-chain streaming application. So that could be using, for Transact Connect, where you could you know, use Connect to open a stream on different chains, or it could be you know, even your own solution. So I know a couple of teams are taking a stab at this, but if anybody who's listening in wants ideas on how potentially to get that done, please contact me and we'll figure something out. The second one, if I remember correctly, Pat, are you loading them? Okay, let's see.
Explain it to boomers. Yeah, so this one was my idea. So there's been some hackathons in the past where people built like some amazing visualization tool or some education app or something, and I like, honestly, those are my favorite because it takes a concept that, you know, only 100 people in the world can understand, which includes like, you know, you guys in this channel right now, and makes it easy so that anyone can understand it. And so the best example of that is like a visualization tool, right? Like showing how do we visualize money, you know, flowing from one account to another. And what does that mean that's different from just taking money out of your wallet? And so, yeah, any user experience or education or visualization tool to make streaming money easier to understand. So that's the second bounty, and that's $1,500. And like, honestly, it doesn't have to be super technical. Like, that could be literally, you know, a presentation that's just like amazing and explains it really well. There's no like technical requirements for that one, I don't think, unless Fran, you know of any.
No, it could be anything, and you could even use upcoming graph that Pat's built. So very soon we'll be publishing our subgraphs that allow you to pull data from all our deployments very easily. So that would be great if you're building a visualization tool. And yeah, if anybody's interested and if you've worked with the subgraph before, just reach out and we'll share that with you in preview. We should be publishing it soon with a bit of a tutorial on our docs as well. And that should be the best way to pull data and kind of you know, display it in a way that's meaningful to non-initiated people.
And our last bounty is build something awesome using Superfluid that makes money more fluid. And this basically just means that money can scale more if it's behaves more like a liquid, because liquids spread out very easily. If you put a liquid, it's going to take the shape of its container. So if the container is the whole world and money is a liquid, then it should cover the whole world, right? So the example here is create a tool for organizations to streamline discrete payments into constant flows. So taking a payment that would be like, once a month and turning that into constant flow.
Yeah. So this could encompass, the DCA app that Shepherd Blue is talking about. It could be the trust that our friend George was talking about, and it could even be, just a way for DAOs to send streams from their multisigs, right? So anything that enables anyone to do something in a fluid way would qualify for this bounty. All right. Well, sounds good. Thanks everyone for joining. Pat, should we close here? What do you think?
Yep. Thanks everybody for stopping by. We'll do this again in probably another 2 weeks. And we'll probably just make this a regular meetup, so
yeah, it'll be good, right?
Yeah.
Just hang out and do some coding. I'd actually like to maybe, do you know of any actually tools so we can do pair coding on Solidity stuff? Is that a thing?
We can find something.
That would be pretty cool, right? So we could hack up something together during the stream.
Yeah.
I think a hosted instance of Visual Studio Code works.
I'm not a Visual Studio Code guy, but I guess I'll have to download it, huh?
Yeah. I'll download it for you, Anchor. I'm also not a VS Code guy, but why not? If it works, it'll be fun. All right.
Alrighty.
Okay. Well, thanks everyone for joining, and looking forward to see what everybody hacks to scale money using Superfluid. Thanks a lot. Cheers, guys.